talk about probability distributions. We're going to learn about one called the binomial distribution. So we're going to do a binomial experiment and figure out the probability of an event either happening or not happening. So let's first take a look at the probability of the following events. So using this spinner, what's the probability it lands on a forward or spin again, or we're going to learn or remember what these symbols meant. So probability of forward, there's two forward spaces. So 2 out of the 8 are forward. So there's 2/8 or 1/4 chance for forward. Okay, there's the top one up here, and then there's another one over here. Spin again, there's once again 2 out of the 8, so 1/4. Now, forward union spin again, so the U means union, so means or at least one of these happening. So we see that there are 4 of those spaces, so it's 1/2 the probability I either get to spin forward or spin again. And then the apostrophe looking symbol means not, it's the complement. So the probability of not forward is all the other spaces. So there's 6 of those, so 3/4. So really we need to remember the complement is always the opposite, so it's everything else. Now today we're going to talk about something called a binomial experiment. So the prefix bi means 2. So a binomial experiment has 2 outcomes. We'll denote them as success or failure. So it either happens or it doesn't happen. And we repeat the experiment with multiple trials over and over again. And each trial has to be the same exact setup, same odds of success or failure. The trials can't affect each other. So one good example is I roll a die, and then I roll a die, and I roll a die, and I'm looking for either a 3 or not a 3. So let's look back at the spinner. Okay, I'm going to create a binomial experiment where I'm going to define success as lose a turn. Kind of sounds weird that lose a turn success, but that's what I'm defining as the event. And then the opposite event is not lose a turn, anything else. So I got to figure out the probability of spinning lose a turn exactly 3 out of 5 times. So the first thing, I got to figure out how many different ways are there to get 3 lose a turns out of 5. And we're going to use a combination here. We're getting in the habit of writing a combination instead of listing every single one of these because it gets tedious and sometimes you forget one. So there's 10 different ways. There's 5 out of these 5 slots, I can choose 3 of them to be lose a turn. The order doesn't matter. So there's 10 different ways to lose a turn 3 times. Next, I need to figure out the probability of the event. So probability of lose a turn, which is 1/4. The probability of not lose a turn, which is 3/4. Now, if it was exactly lose a turn, lose a turn, lose a turn, and then anything else and anything else, I can say that's 1/4 times 1/4 times 1/4 times 3/4 times 3/4. Because the events are independent, so we could just multiply them together. So the probability of exactly that happening is 9 out of 1024. Now, this can happen 10 different ways, so I got to multiply that by 10. This result, 9 out of 1024, multiplied by 10 to get about 0.088. Now, I don't want us to go through this whole process every time, so we created a binomial probability formula. Okay, math decided, okay, well, we take how many ways there are to do it, so NCR, and multiply it by p to the r, and multiply that by 1 minus p to the n minus r. And I'm going to show you what each part of these means. So n is the amount of trials. How many times are we doing this? R is how many times do we want to be successful? And then 1 minus p and p, so p is going to be what's the probability of success, and 1 minus p is what's the probability of failure. So these are the complements. And then if we have r successes, we have to have the remaining to be failures. So let's go through a problem. Okay, same problem. I want us to come up with and see how the formula works. So we're spinning the spinner 5 times and we want exactly 3 successes. So 5 trials, n equals 5. 3 successes, that means r equals 3. The probability of success, p, we saw, is 1/4. And q is the other probability of failure or not success. So that's 3/4. Okay, now we have everything we need to put it into a formula. So 5 choose 3, was how many different ways there are to do it. We want 3 successes, and then we want the remaining, which 5 minus 3, you could put a 2 here. So this whole thing would be 2. We want 2 failures. So 1/4 to the third power, 3/4 to the second power, and 5c3. If you multiply all those in your calculator, you'll get our 0.088. So that's how to determine a binomial probability if they tell you we want exactly this many successes out of this many trials.